Hello everyone and welcome to Understanding Physics, in which I will help you to understand physics and try to study it through real data sets. So, in this series we will cover General Physics 1, which covers why a apple falls and all the way to why waves exist until you will understand about why an engine works. So, in this introduction, I will cover the 19 topics of General Physics 1 from the book Essential University Physics by Richard Wolfson. So, to cover General Physics 1, we will cover doing physics, in which how do we use physics? Like, why do we need to use units? Why do we use significant figures? And also, why is physics the best understanding of the universe currently through the mathematics and the models that it takes so that we could understand the world only through computations. The second of all, we will talk about motion in a straight line, in which we will discuss the movement of a particle in one single direction. For example, a ball falls towards the ground with a certain acceleration. This could be discussed as the position to be the height minus the velocity multiplied by the time, subtracted by the gravitational force, the gravitational acceleration divided by 2 of the time squared. This formula will be derived in this section. The third section is motion in two-dimensional and three-dimension, in which we will talk about how a particle moves in two or three different dimensions. For example, if a particle is shot in a certain direction and a certain angle with a gravitational force, it will have a form of a parabolic motion, which can be derived through only the mathematics, as you can figure out where the particle is at a certain time and you would know its position as well. Next up, it is about the force and motion, in which we will talk about the relation of force and motion, in which one of the most popular formula in physics is F equals to ma, in which the force relates towards its movement or the acceleration. The fifth chapter talks about how to use Newton's law, in which we will discuss about different examples that we have in the world and discuss it through the force. Next up, we will talk about energy, work, as well as power, in which we will discuss why it is easier for you to pull an object towards a slope compared you pulling it straight up, which relates to the power or the change of work over the change of time. And this work is basically the force multiplied by the distance. So long as you know each of these different variables, you could know what's the best way for you to do a certain task. But you cannot do a certain task without using energy, since there is the conservation of energy, in which energy cannot be created or be destroyed. For example, if you have an object at a certain height and it's dropped, it will convert its potential energy and convert it all into kinetic energy. The next chapter talks about the gravity. For example, if you have if you have a particle, um, if you have a planet and and also another planet, they they will they will interact between each other, and you would have something called the gravitational force, which is the negative g of the first mass multiplied by the second mass over the radius squared. And this will later relate towards why do we have the gravitational acceleration to be a constant, as well as the energy and the velocity needed for you to get out of its orbit. The ninth chapter talks about systems of particles, in which we will discuss how do you transform a system of particle to be only one particle. For example, if I have a rod and given a force, as long as I know where the center of mass is, I could predict where the object will be as long as its center of mass is treated as a particle and the force treated towards it is the same. But this doesn't cover how the system will rotate, and this is where the next chapter comes in, which is the rotational motion. But apart from actually discussing the center of mass, we will also discuss the momentum which is conserved during a certain moment, which is the mass multiplied by the velocity. Momentum could also be related as Newton's law, and this will be discussed in this section. Rotational motion will discuss how a system would spin. For example, if I apply a force in this direction, this guy will have a certain angular velocity and angular acceleration, and this can be discussed using the rotational version of Newton's law, which is called torque, and it's related to the moment of inertia multiplied by the angular acceleration. Next up, we will talk about rotational vectors and momentum, in which we will talk about certain mathematics behind rotational motion, as well as the angular momentum, which is the angular counterpart of the momentum, which can be denoted as the L, which is equal to the I multiplied by the omega. And we will discuss this through certain experiments. Next up, we will talk about static equilibrium, in which the system does not move. For example, you could have a bridge that doesn't move, even though I subject it to a certain force, because it is spread out through the entire system, and thus you would understand why this bridge does not move. And this is very important for a civil engineer to think about. We have covered about the force and motion, but there are other things to discuss, such as the oscillatory motion. The oscillatory motion describes a motion which is repeated over a certain time. For example, if you have a particle attached to a spring, it will go up and down continuously, and it can be related as like a sign of something, which is called the position, and this is what we call as the oscillation. And this is the basis on how you make a clock, which has a certain period that defines a certain time. The next chapter talks about wave motion, in which we will discuss that if you have a system of particles exhibiting a oscillatory motion, you could have it to form a wave, and it can be described with a wave equation of del squared of f over del x squared to be equal to the del squared of f over the del t squared divided by the speed squared. And this is what relates every single wave. The 15th chapter talks about fluids, in which how a fluid interacts and how it flows. For example, why do you go to the bottom of the ocean and you would feel much more pressure in yourself? It is because of the hydrostatic pressure. Another part is that we will discuss about if you have a tube, you can describe its velocity through two different equations: the continuity equation, which is AV is constant, as well as the Bernoulli equation, which is the pressure added by the half of the rho of the v squared, which is the kinetic energy, and as well as the hydrostatic pressure, or the potential energy. And this should be constant. This will later be derived in this section. After we talk about fluids and the systems of particles, we want to discuss about heat. And this is where the chapter temperature and heat comes in. In this chapter, we will define what is a temperature as well as what is heat, which is a form of transfer of energy, Q. The next chapter talks about how materials behave under certain conditions. For example, if I have a material and I heat it up, this material could later melt away, turning into a liquid compared to a solid. And this will later convert again to be a gas, or it could also become another form. For example, liquids also expand when you increase the heat, in which the volume will rise following the equation of beta v delta t, which will later be discussed in this chapter. The 18th chapter will discuss about heat, work, and the first law of thermodynamics, which is one of the most known law of thermodynamics, which is the Q plus W, the change of it, is always the change in the internal energy. And if you can set the temperature to be constant, the internal energy will be zero. The change of the internal energy will be zero. And this is one part in which an engine works. Finally, we will discuss about the second law of thermodynamics, which discuss about why we cannot have a why we cannot have a perfect engine, which relates towards the entropy or the dq over t. And so this is the entire topic of General Physics 1, in which we will try to understand deeply and develop an understanding so that we can describe the whole world only through this. Although there are certain conditions in which these physics will apply, but that will be in a later series. So I hope you all will follow this journey to understand physics and to explain physics and apply it to your daily life. That's all. Thank you very much, and I will see you on the next video.